Okay, problem number one. The derivative of the graph of f of x is given below. Again, for emphasis, this is f prime. So this is like the homework problems we've had. We're trying to answer questions about f based on the graph of the derivative. So the first one, part A, asks to list the coordinates, the x coordinates of the function where the critical points, find the critical points of the function. Does anyone want to chime in? How do we find the critical points?
The derivative equal to 0.
Derivative equals 0. Okay, where's the derivative 0?
The 4 and 9.
Yes. And
9.
And 9. Yeah, I lost my pen.
I like that one.
Let's try. So 4. There we. Nope. Oh, I don't want that. Have that. There it is. 4 and 9 are x coordinates for the critical points, places where the derivative is 0. On what intervals is f increasing? F is increasing when what?
When f prime of x is positive.
F prime of x is positive. I'm going to go ahead and just make a sign chart here for the derivative. Critical points are 4 and 9. And from the graph, when x is bigger than 9, is f prime positive or negative?
Negative.
Between 4 and 9?
Negative.
Same again, and then to the left of 4,
Positive.
positive. Okay, so we see f is going up, 4 down, and down again. So at 4 is a local what?
Max.
Local max. And 9? Neither.
Wouldn't 2 be a critical point as well?
Okay, so what's going on at 2?
The inflection point.
Okay, so yeah, so at 2, the slope of f prime is 0. So we're going to get to that in a minute. But for part A and B, we're interested in where f prime is 0. So that's at 4 and at 9. Does that make sense?
Kind of. No, it's just that at 4 seems like it's the slope is not 0. It's still.
Okay, so the slope of f prime, but the question is about the slope of f.
Oh, okay. I got it.
Okay, and I think we've already answered B, increasing to the left of 4. So let's see, we said in this problem, the domain 0 to 11. Yeah, I know. 0 to 4 is where it's increasing. Okay, concave down. So concave down, here, let's do this thing. We know f is increasing. This is what we just did. When f prime is what?
Positive.
Positive. And if we turn it around, f is decreasing when f prime is negative. Now if we take those and turn them into statements about the second derivative is positive when f prime is increasing, and the second derivative is negative when f prime is decreasing. Is that good? Positive second derivative means what about f?
Concave up.
Concave up. Concave up. And that's what we're after here. So in part C, concave up, we want to look at, if we want concave up, then we want f prime to be increasing. Where is that happening?
Whenever the x is, wait, no. Whenever the slope derivative is increasing. Is the slope positive?
Okay, when the slope of f prime is positive, so what x values of that?
Yeah. What x values? So 2 to 6.
Okay, 2 to, so
decreasing.
Yeah.
That's when the slope is decreasing.
Okay, so slope is 0 at
0 to 2.
At 2. So here, let's make a sign chart. Well, no, let's not do that. let's just see if we can answer it by looking at this. Again, this is the graph of f prime, so we can just look at it and answer, when is it increasing? When is f prime increasing? So when is f prime going up?
0 to 2.
0 to 2.
6 to 9.
Yeah, 0 to 2 and 6 to 9. Okay, so we see 2 does in fact turn out to be an inflection point. Okay, good. Any further questions on that one? See, make sure I'm not missing anything on the chat. It probably pops up if I get, oh wait, here we go. Okay, approximation. I think we're going to hit one of those on this. We'll come back to that later on if we need to. Let's go on to number 2. Select. Okay, 2, intervals of increase. Step 1, what's the first thing we need to do?
Take the derivative. Take the derivative.
Okay, so f prime, derivative e to the anything, e to the anything.
Times.
Let's do that. Yeah, derivative anything. Set it equal to 0. And it's already factored for us, so we can break it apart into 2 equations. The negative x squared equals 0, negative 2x equals 0. Where does e to the negative 2x squared equal 0?
1.
So how would you solve that? What would you do to undo the e?
ln.
ln. So if we ln both sides, we get negative x squared equals ln 0. And if you ask your calculator what ln of 0 is, what's it going to say?
Error.
It's going to say error. So that's warning us that there is no way to solve this equation. In fact, e to the anything is always going to be what?
Positive.
It's always positive. Good. Yeah. So no solutions from this part. Over here, we get the solution x equals 0. So just one critical point. Number line. So when x is negative, if we plug in a negative number, well, we just said e to the negative x squared, that's always going to be positive. So the only thing that really matters is the second term. If we plug in a negative number there, what are we going to get?
Positive.
Positive. Yeah, so positive when x is negative, and if we plug in a positive number, this second term is negative. Okay, so let's see. The question was, when is it increasing? Increasing to the left of 0. So negative infinity to 0. Okay, is that okay? Second derivative for concavity, product rule. Let's do the derivative of the first, e to the negative x squared times negative 2x, again, times the second, plus the first, times the derivative of the second. Okay, what do we do with that?
Take out e to the negative x squared. Or you can simplify first, but.
What's that? Or do what first?
Factor.
Yeah, let's do that. E to the negative x squared. So left over here, I've got 4x squared. And from the second term, just a minus 2. Set those equal to 0. Again, e to the negative x squared equals 0. Nothing to see there. 4x squared minus 2 equals 0. Isolate the x. And we're going to remember when we take a square root both sides, we're going to also do what?
Plus or minus.
Plus or minus. Okay, so 2 potential inflection points. We'll make a number line. Negative square root of half. I'm going to like this because I have nice numbers to plug in. Give me something bigger than square root of half. Give me like 1.
1.
Okay. What you really need to worry about is that second term, second factor, because this first factor is always positive. If I plug in 1, 4 times 1 minus 2, that's positive. If I give me something between negative root a half and root a half.
0.
0. Plug in 0. The second term will be 0 minus 2, so it's negative. And then what? Plug in -1, back to positive. Okay, so concave up, negative, whoa, that's really good. Negative infinity to negative square root of half, and then also from square root of half to infinity. Good? Good?
Good.
Questions on that? All right. Sailing along, delete that. Numbers, oh, L'Hopital, oh, well, maybe L'Hopitals. Let's do these one at a time. Now I'm getting both.
I don't know why.
Okay, first thing we're always going to do for a limit, first thing. It's not going to work, we're going to do it.
Oh, plug it in.
Plug in. What's cosine of 0?
1.
1.
Okay, so we get 1 minus 1, we get 0 upstairs and 0 downstairs. Should we go for it? L'Hopital?
Yes.
Yes, L'Hopital. I don't know. LH. Derivative of cosine of anything.
Sine.
Negative sign.
Negative, good. What else do we get?
Times the derivative of anything.
Times derivative of anything, so times derivative of 3x. Derivative of 1 is 0. Downstairs, 2x. Now what?
Plug it in again.
Plug in again. Sine of 0.
0.
0. 0 over 0. Do what?
The law hospital.
Do it again, yeah. It's
I get this one. I actually know how to do this one.
good,
It's
good.
when you move to the.
And you can see each time we do the derivative, the downstairs is getting knocked down in the degree. Okay, derivative sine. Cosine 3x. Kick out another 3. The 3 that was there, does that look okay? Stairs is now just 2. So what do we have? Cosine of 0 we said was
1.
1. So negative 1 times 3 times 3 over 2. Okay, not too bad. 2 L'Hopitals. Let's plug in for part B. Where is 5 over, what's 5 over infinity?
0.
0.
Okay, so it's 1 is the base, but the exponent's going to infinity. How do we handle that one?
Away. No one
9.
hits.
Log.
Good. Yeah, what's going to be the clue for that? What's the clue that this one was a log 1?
There's an x in the exponent.
Okay, we got variables in the exponent and variables on the ground. So we see that we've used this trick several times now. I'm going to call L the limit. Limit as x goes to 1 plus 5 over x. Ln it.
Why? What is he doing?
Okay, and the reason I do ln is
Win the ball.
bring the 2x down. What happens when we plug in infinity now?
You get infinity times 0.
1.
Good. Infinity times natural log of 1, which is 0. Now they're in determinate form. What do we do with those?
We factor it.
So I've got it factored.
Lollipop rule.
Bring something down.
Downstairs, we like the fractional forms. Should we send the x or the log down?
X.
Send x down. I'm going to leave 2 upstairs. He's not causing any trouble up there.
Which one is it
I'll make it x to the -1. Okay, and now when we plug in, it's natural log of 1 is 0 upstairs, and downstairs infinity to the -1, 1 over infinity. So we finally got to a L'Hopital form. Okay, here comes L'Hopital's rule. LH. Derivative of natural log of anything.
1 over anything.
1 over anything. And then
Times the
Derivative.
derivative of anything, and again, 5 over x, that's the same as 5x to the -1. So I'll do negative 5x to the -2. Downstairs, again, x to the negative 1, negative x to the negative 2. Now what?
Cancel like
Simplify.
terms.
Yeah, let's cancel. We can cancel x to the negative 2. You can even cancel these minus signs. So we get, nope, I want it to be black. Okay. Limit as x goes to infinity. 2 times blah times 5. Now what?
Plug it in.
Plug in, yeah. We can just plug in 2, 1 over 1 plus 0 times 5. Are we done?
Yes.
Yeah, not quite. That's ln of L. How do we unlog? Good. All right, that was a good one. Questions on that? I haven't checked the chat in a while. Oh, chat. How do I get, oh, Anna, did you get, oh, you got it?
Never mind.
Ooh, okay, here's an approximation one, a linearization. We'll hit that. Okay, linearization. What is linearization? It's just a fancy word for what?
Slope of the tangent line.
Okay, the whole tangent line, right? We want the whole equation of the tangent line. Equation for any line, what are the ingredients?
Slope and point.
Okay, let's get the point first. What do I have for the point?
1.
1. What's the y coordinate?
8 over radical
4.
1 plus 3.
Yeah, f of 1, 8 over square root of 4. So is that 4? Okay, so 1 comma 4 is our point. And how do we get the slope?
You
Okay, here let's rewrite it as 8 times x plus 3 to the negative 1/2. Reach up, pull the minus 1/2 down. X plus 3 to the negative 3/2. So we have to chain rule?
No, because it's 1.
Yeah, the derivative of x plus 3 is just 1. Okay. So slope will plug in 1 again, f prime of 1. 8 times negative 1/2 times 4 to the negative 3/2. Oh, let's see. Calculator. Negative 4. Let's see. We're going to do 3 things. With the exponents telling us sign 1 over. The 3 means we're going to cube, and the half means square root. Look good. Negative 4 times 1/2 cubed. Negative 1/2. I have the answer here. I'm going to make sure I'm doing this right. Okay. Slope negative 1/2. Point slope. Above point slope y minus 4. Negative 1/2 x minus 1. Or move the 4 over, y equals 4 minus 1/2 times x minus 1. If we get fancy, linearization, L of x. Okay, that was a lot of writing, but really mostly it was just simplifying. Not a big deal. Slope is f prime of x at the point. We got the point. Finally, use your linearization to estimate. What are we going to plug in? What is
2.
8 over square root of 5 is f of what?
F of 2.
It's f of 2. Good. What we need to get a 5 in the denominator is x2. Okay, so we'll plug 2 into our linearization. L of 2 is 4 minus 1/2 times 2 minus 1, or 3.5. Again, notice if you plug in 8 over square root of 5, that's going to be close to 8 over square root of 4. The answer is 4, and then plus this little adjustment. Okay. Any other questions on that one? Throwing it away. Finally, the optimization problem. Would you be excited if you got this one?
Yes.
Yeah.
Yeah, because
This one's not bad?
Yes, good, perfect.
Okay.
Can I count on that?
Do you want?
Yeah.
It's already written. I can't change it.
Blink once if it's that one.
Let's do our 5 steps. Step 1,
draw a picture.
picture. A box. I am really good at drawing boxes. I remember being so excited when I first learned how to draw a 3-dimensional box.
Okay.
It's really good. How should I label it? Suggestions for variables?
ABC.
ABC, okay. I overruled that today in class, but we'll go for it. A, B, C. Sounds good. Material. Okay, so what's the next step?
Find out the optimizing quantities.
Good. What are we optimizing? Cost, good. Least expensive box, so we're optimizing cost. Go ahead and give that a name. No, oh. He's already taken. We did M.
For dollar sign.
What? M for money. Okay, next step.
Equation.
Yeah.
Equations, yeah. Let's see, M. So we've got sort of 5 sides, right? We've got the base, the left and right sides, and the front and back sides. Let's look at the base. What do you know? The material for the base costs $4 per square foot. So how do we actually calculate the cost of the base?
Base is square,
Oh, okay. Base is a square. So what does that mean?
so it's b squared.
Okay, yeah. So should we get rid of A and just observe that A and B are the same?
Yeah.
Good. Okay. So the area of the base is B squared. What's the cost of the base?
4b squared.
Yeah, and notice how the units help you out. $4 per square feet times square feet gives you dollars. Let's see. The left and right sides, they are $3 per square foot. What's the area of the left-right sides?
B times C.
B times C, and we've got 2 of those, so I'll put a 2 in there. And then the front and back, what about those?
B times C.
Yeah, they're the same, so we can use B again. 3 and 2BC. Okay, so there's M. Again, we're excited because we've got what we're trying to optimize. What else do we need?
The auxiliary equation.
Auxiliary equation. How are we going to get that?
The volume is 8.
Good. Volume is 8. 8. So 8 is ABC or BBC, B squared C?
C.
Which one should we solve for? Oh no, go away.
C.
Which should we solve for, B or C?
C.
B. Okay, we could solve for B, but I don't want to take this route.
C. C.
So yeah, if we just divide B squared both sides, then done. I don't have to square root, so I'm gonna go with that. Okay, so now we've got. I'm gonna go over here. M is 4b squared. Leave that alone. Here, let's consolidate this first. How much is that total?
4BC.
That's 12b. So I'm going to call that now 12. B and C is being replaced with 8 over b squared. Okay, the dreaded step 4 has been completed. Now what?
Derivative.
Derivative. Should I do the derivative now? Or should I do something else?
Simplify.
Simplify, good. 4b squared plus, what can I do to simplify?
Cancel a B.
Cancel a B.
Yeah, give me a red. Yeah, the red. I'll take pink. We can cancel B from the top and bottom. Okay, 8 times 12. 96 over B, or 96 B to the negative. Time for derivatives. M prime 8B minus 96B to the negative 2. Next.
That equal to 0.
Is that equal to 0? All right, how are we going to solve that?
Take out B to the negative second.
Okay, I'll factor out B to the negative second, which is a good choice. It's the lowest exponent. If I factor B to the negative second from B, what's left over? What goes on the exponent of the first B?
The third.
Third, subtract, right? It's like 1 minus negative 2. Okay, and so let's see. Set these both equal to 0. Let's go right up here. B to the negative 2 equals 0. Does that give me anything?
No.
Nope. 1 over B squared can't ever be 0. No solutions there. And then 8B cubed minus 96. Set that equal to 0. I'll just isolate B. B cubed 96 divided by 8. That's, well, I can reduce it some. I'm just going to go ahead and write B as cube root of 96 over 8. Okay, good. How do I find what? C. How do I get C?
Plug it back in.
Plug it back in. Yeah, we have this nice formula for C. C is 8 over cube root of 96 over 8 squared. Morally, I'm going to go up here in the corner. Morally, I feel like I want to make sure that this really is the local min. So I'll do a first derivative analysis. C, no, it's M. M prime. If I plug, where's M prime? M prime's right here. Actually, yeah, that's fine. If I plug in something, no, let's look at this one. If I plug in something bigger than square root of 96 over 8, like a million, this term will be positive. The other term's always positive. If I plug in something like 1, I can see this second fact will be negative. So that does confirm it's a local, in fact, global min. How was that? Was that good?
Mm-hmm.
That was all of them. Okay, so for the particular license of Zoom I have, I can only record 40 minutes. I'm going to stop the record. I think I won't cancel the meeting though. So if it does, I'll get right back on, but I am going to stop the record. Or